Okay, so I really like this task because I find it's got several uses depending on where you are on a pupil's journey. So you might want to use it lower down the school for some really engaging practice on multiplication and some nice wow moments. And then later on, you might want to revisit again, maybe with a bit more algebra involved and looking at difference of two squares. So to begin with, you can use Cuisenaire rods if you want, or you can just use square paper and draw them. You get the pupils to make, say, a 4x4 square or 5x5 squared, it doesn't really matter, and ask them to calculate its area. So this one would obviously be 4x4, which is 16. And then by definition of the task, this closest rectangle. So we increase the length by 1 and decrease the width by 1 to give us this 3x5 rectangle here, and compare the two areas. Now it's nice to do it with actual Cuisenaire rods or at least diagrams of the squares, but there's nothing to stop you doing it solely in the abstract as well. And 3 times by 5 gives us this area of 15. And what do you notice? Well, hopefully they'll say that it's one less. And it's more profound if you actually put these areas on top of each other. And you can see you always have this missing square in the corner here. The area is always one less. The closest rectangle has an area one less than its square. So you do a bunch of these with the class, and hopefully you get to the conclusion that it doesn't matter what square you start with, its closest rectangle always has an area of one less. Then we can say, okay, what if we take it a little bit further? What if we look at the next closest rectangle? So what I'm essentially meaning is, what if we keep subtracting 1 from the length and adding it to the width? So this would be a 2x6 rectangle, which obviously has an area of 12. And pupils tend to be a little bit disappointed here because they want it to go 16, 15, 14, 13 and so on. And you might have to tell them at this point, don't be disheartened. Maybe if we carry on going, maybe we will spot a pattern. And again, if you want to build this out of Cuisenaire rod, it might give you a clue as to what this pattern might be. So let's just build this 2x6 rectangle on here, and you'll see that we end up with this 3 missing from it here. So we've subtracted 1 there, and now we've had to subtract 3 here. And is it a coincidence that here is looking like a square? You might not want to reveal that to the pupils yet, but it plays a very important role. So let's carry on. So 1x7 will be the next one, which has an area of 7. And now we start to see this pattern forming nicely. Now it's subtract 5, so we can make these conjectures. The next one is probably going to be -7. Now we're into the realms of interesting discussion. Is a 0x8 even a rectangle? Well, of course it's not, but it still does follow the pattern. It would have an area of 0, and that would be -7, which does follow this pattern going on. And then we can start to linking it. Okay, what's going on here if we actually build the blocks? Why is it always going to be squares that we keep building? And what happens when you add the odd numbers together? Well, 1 is a square number on its own. 1 plus 3 is 4, a square number. 1 plus 3 plus 5, which is 9, a square number. 1 plus 3 plus 5 plus 7 is a square number. So we're making all these links with various areas of maths, and all this does link in eventually to the difference of two squares. Okay, so taking this task into the abstract a little bit then, the next thing I like to do is write down 100 times 100 on the board and ask the pupils what the answer is, and hopefully get 10,000 pretty quickly. Then say, okay, what about 99 times 101 then? And hopefully they can link it to what they've just been doing with the smaller numbers and say the answer should be 9,999 because it should be one less. And then you've got a really good hook or incentive for pupils to actually check this using either their grid method or their traditional long method for multiplication. And then you can go further. What about 98 times 102? Well, if you remember those patterns, that one should be another 3 off. So it should be 9,996. And they're really happy when they actually get that answer by checking it. And it's really good for you as a teacher because you know what the answer should be. And then further on, you might do a ... for example. What do you think, say, 95 times by 105 would be? And then we can start linking it to this idea of square numbers. Well, the first one, when we subtracted 1, it was 1 away. And then when we subtracted 2, it was 1 plus 3, which is a square number away. So here we're subtracting 1, 2, 3, 4, 5 away. So it should be the 5th square number away from 10,000. So we can make these conjectures that it should be 10,000 minus 25. So we're hoping it should be 9,975. And then they can check that and they can see that they are correct. Now, by the time we've got this far, we're basically not too far away from a more formal definition of difference of two squares, which I probably wouldn't do with the younger pupils, but certainly with older students, I'd maybe revisit this task, and we'd come to the conclusion that actually a minus b multiplied by a plus b is in fact equal to just a squared minus b squared. So, I hope you enjoyed this, and as always, put your thoughts and comments in the thread below.